Divya,
Call is now recorded.
Divya, Gat Pratmesh Shivaji, Jyoti,
Present, sir.
okay, Kiran, Lakshmikant, Mantesh, Mantesh, Mole Prem,
Yes, sir.
okay,
Sir,
Mole
Mantesh
Prem,
present.
okay, I am marked. Mole Prem, Nagesh, Nandish,
Present, sir.
okay, Pooja,
Present,
right,
sir.
Pramod Kumar, Praveen, Priyanka, Sandhya, Santosh Pujari, Santosh Sonar, Shahbaz,
Present, sir.
okay, Shafia,
Present, sir.
right, Sridhar, Srushti,
Present, sir.
okay, Siddharth, Siddharth Patil, Supriya, Vandana, Vasant, Vedatta, Yogesh, Mahesh, Balesh, Taik Mohammed, Praveen Rathod, Abhishek,
Present, sir.
okay, Aishwarya,
Present, sir.
right, Amanullah, Bandodkar Tanay Mohandas, Bhaurav, Shodhan,
Present, sir.
right, Devanar Anil Kumar Shekappa, Nand Kumar, Pramod, Rohini, Rohit, Shashidhar, Sridhar,
Present, sir.
right, Snehal, Vaishnavi, Saish, Kartikyam, okay. Anybody else? Right. We were discussing about data serialization in the previous class. Let us continue with that. Is the screen visible, students? Screen is visible?
Yes, sir.
Right.
Yes, sir.
The second program, fine. The second program in the data serialization, take this program, write a C program to send out the value 44H serially, 1 bit at a time via P1.0. The MSB should go out first. Write a C program to send out the value 44H serially, 1 bit at a time via P1.0. The MSB should go out first. Note down this. I hope you all noted down here. Noted down? Yes. Okay. So let's first I'll explain the concept. Then I'll explain you all the program. In the last program that we took up in the previous class, the program was write a C program to send out the value 44H serially 1 bit at a time via P1.0. The LSB should go out first in the previous program, right? Here they are asking to send the MSB first. Through P1.0, it has to go out of the microcontroller. Now, let us say here there is MSB. Okay, there is MSB bit. Then we are having the other bits. So it starts with the MSB bit. Say it is 0, 44 they have given 0, 1, 0, 0. Then again we are having 0, 1, 0, 0. 0, 1, 0, 0, 0, 1, 0, 0. On the other side, we are having P1.0. On the other side, we are having P1.0. Now, what they say is the MSB, that is this bit should be first sent out. That means what I have to do, this bit, whatever this data is given, that I am storing it in the accumulator. So this is nothing but this data, whatever is there, 0100, 0100, this is stored in the accumulator. The first bit, that is MSB bit, will be ACC 0.7, ACC accumulator 0.7. This bit 0, this is accumulator 0.7, correct? This is the MSB bit. Now this bit should be stored in P1.0 and from there it is sent out of the microcontroller. Now in the previous program what we did, we assigned the LSB to P1.0, that is this bit LSB we assigned it to P1.0 and then we shifted the bits left. We shifted the bits right side. Okay, we shifted the bits right side. Here we are supposed to shift the bits in the opposite direction, that is in the left side. Okay, now this is 0, that is MS bit. This will be stored in the P1.0. So it will be 0 here. First time it is 0. Then next, if I want to send from P1.0, it is sent out of the microcontroller. Then next, if I want to shift this next bit, then I have to shift the bits left. Now if I shift the bits left, this one will be stored in the position of MSB. Now the next time the data will be 1 triple 0, 1 triple 0. That is these 7 bits 1 triple 0, 1 0 0, 1 0 0. Then we have this bit which is rotated to the left side, so it is 0. MS will be stored in the position of LSB. Okay, so this is shifting left. Now this bit ECC points on MSB is assigned to P1.0. That means now P1.0 will be storing 1. That is the ECC 0.7. Accumulator register 7th bit. That is D7th bit will be stored in P1.0. Like this, all the 8 bits are shifted left by 1 bit, right? When we repeat the shifting operation 8 times, all the 8 bits will be shifted. And when they shift, they will be taking the position of MSB. From the MSB, we are assigning it to P1.0, where they will be stored and sent out of the microcontroller. This is the logic of the program. Now, based on this logic, we have to write a program here. This logic is clear here? Logic is understood? Yes? Logic is understood? I hope logic is clear here. Srushti?
Yes, sir.
Logic is clear?
Yes, sir.
Logic, understood the logic? Okay. We'll
Yes,
write the
sir.
program. Fine. Okay. We'll write the program here. Start with the header file. Hash include reg51.h, reg51.h. Then before writing the main function, we have to define S bit P1B0. P1B0 is equal to P1.0. This we are writing as P1 inverted V 0. Then one more we have to define S bit, that is for the MSB bit. MSB bit, S bit, register A, register A, register A, MSB is equal to ACC 0.7, accumulator 0.7. Okay, accumulator 0.7, right? Then next, start with the main function. Start with the main function. Void main, void main. Then next, how to initialize the variables that we are using in the program. Unsigned character, unsigned character, right? The data, whatever is given, that data, it is 44H, SFT byte, shift byte is equal to 0x44. 0x44. This is the data. Next, initialize the loop index, unsigned character x, unsigned character x. Then write the for loop, for loop. Before writing the for loop, we have to move the data which is there in the SFT byte, shift byte into the A register, right? Because we are moving from A register to pin P1.0, we are moving the data from MSB bit of accumulator to P1.0, and from there we are shifting out of the microcontroller. We are sending out of the microcontroller. Therefore, what I have to do is ACC is equal to shift byte, SFT byte. SFT byte. That means this 44H will be stored in accumulator in the A register. Okay. Then write the for loop for x equal to 0, x less than, how many times we have to repeat rotation? 8 times. X less than 8, x plus plus. Then what should be in the for loop? We have to assign P1.0 to ACC 0.7. P1.0 should be assigned to ACC 0.7. P1.0 is P1B0. ACC 0.7 is register A MSB. That is P1B0 is equal to register A MSB. P1B0 is equal to register A MSB. Okay. That means this register MSB is ACC 0.7. The D7th bit of accumulator that will be stored in P1.0. MSB bit will be stored in P1.0. Okay. Then after we are assigning, that is MSB bit will be stored in P1.0, we are sending out of the microcontroller. We have to get the next bits, that is the remaining 7 bits. They should be stored in MSB. From MSB they have to be copied into P1.0, and from there they have to be sent out. Now to get the remaining bits in the MSB position, we have to shift the bits left. That is ACC is shifted. ACC is equal to ACC less than 1. This is for shifting left. The arrowhead is pointing to the left side, so it is left shift. ACC left shift by 1 bit, that will be stored in accumulator. First end the for loop, then end the main program. This is the program for sending the value 44H out of the microcontroller through pin P1.0 and MSB will be sent out first. First the MSB bit will be sent out, and then the remaining bits, all the 8 bits will be sent out by bringing them to the MSB position. From MSB position, they are copied to P1.0, and from there it is sent out of the microcontroller. Right? Hope everyone understood this program. Any difficulty here in this program? Any difficulty in this program, Mantesh?
No, sir.
This program is clear?
Yes, sir. Clear, sir.
Okay, fine. Next, we'll move to the next program. Take the next one. Write a C program to bring in a byte of data serially 1 bit at a time via P1.0. The LSB should come in first. Write a C program to bring in a byte of data serially 1 bit at a time via P1.0. The LSB should come in first. Note down the program statement. I hope you noted down the statement. Write a C program to bring in a byte of data serially, serial communication, 1 bit at a time. We have to bring the data into the microcontroller, that is into the A register of the microcontroller through the pin P1.0. That is, from outside we are bringing the data serially into the microcontroller through P1.0 pin. Then how the data is brought inside? The LSB should come in first. The least significant bit of the data that should be stored first, and the next bits should be coming next. After the LSB bit, the next bits, right, that is D1, D2, D3, D4, D5, D6, D7. They should come next. Okay. Now, if we want to write this program is slightly different from the previous programs. In the previous programs, we are sending the data out from the microcontroller. Here we are bringing the data into the microcontroller. Here we are bringing the data into the microcontroller. Okay. This is a difference between these programs and the previous program. Let me explain the logic first. Now here, what they are saying is the LSB should come in first. The LSB should come in first. Now let us say the data is, we'll consider the same data, 0, 1, 0, 0, then 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0. Let us consider the same data. Okay. Now here, what they are saying, LSB, that is first 0 bit, 0, 1, 0, 0, 0, 1, 0, 0, 44H. First, this 0 bit should be stored in P1.0, right? That is, from P1.0, you should get this first, and then the remaining bits should be followed. Now, how to get that? Now, what we have to do is, we have to assign pin P1.D7th bit of accumulator, that is register A, 7th bit to P1.0. Now, when we assign the D7th bit of accumulator of microcontroller to pin P1.0, in P1.0, first we are getting the first bit, that is LSB. This bit is brought first. Say 0 it is. It is 0. Okay. So 0 is brought first. Then from P1.0, we are assigning it to MSB bit, that is D7th bit. Here we are storing 0 in MSB. We are storing 0 in MSB. Once we store that 0 in MSB, then next if I wanted to move it to LSP position, this is already LSP 0, correct? Now where it has to be in register A, can it come to MSB position? Can it come to MSB position? This LSB is there. Can I take it to MSB position and say that my data is correct? What will happen to the data if I do like that? Data will be wrong, correct? Data will be wrong, is it not? If I take this 0 and place it here, then it is already 0 here, that is fine. But next time 1 it is. So instead of 1, if I put this 0 at here, next position, what will happen? The data will be wrong, correct? So what I want to say here is, first the LSB, whatever is stored in P1.0, this LSB 0, this bit, it is brought to D7th bit, it is copied to D7, assigned to D7 of register A, then it is stored here. Then next time what is done is register A is shifted right. This register is shifted right. That means this is 0 which was there in D7 position, that will come to the D6 position. So here 0 will come to the next position, D6 position. Suppose say the next bit is also 0, right? So that 0 will come here. The next bit is 1. Next bit is 1. So 1 will move here. From we are storing it in P1.0, right? This is second bit is 0. Then third bit is 1. Okay. So here what will happen? Because of this left shift, because of the left shift, now 0 0 is there, next bit will be 1, this bit will be 1, this will be stored. So like this, every time it is shifting right by 1 bit. Lastly what will happen? The same data what we have given as input to the P1.0, the same will come out and will be stored in the register A. That means here in register A, the data that will be stored is 0 1 0 0, then 0 1 0 0. That is the same data what we want to send it to the microcontroller, same data will be stored, right? So MSB, what is MSB? It is 0, correct? Here also it is 0. Next bit is 0, this is also 0 here. Then this is 1, next bit, this is also 1. The same data whatever we want to send, that will be available in the A register of the microcontroller. Clear yet? Now for this we have to write a program now. Let us write a C program. I hope logic is clear. Nandish, logic is clear? Nandish?
Yes, sir.
Okay.
Yes, sir.
Okay, fine. Let us write a program. Hash include reg51.h, reg51.h. Then define the variables that we are going to use in the program. S bit, that is P1.0 we are using here also. So it is P1B0, P1B0. This is equal to P1.0, P1.0. Okay. Then S bit. Okay. Then register A, here which bit you have to take? D7, MSB we have to take. We are shifting from MSB. So register A, MSB, register A, MSB is equal to P, that is accumulator 0.7. It is ACC 0.7. Okay. Then write the main function. Void main, then initialize unsigned character, shift byte, they have given the value here also. Shift byte is equal to 0x44, 0x44. Okay. Then loop index unsigned character x, unsigned character x. Okay. Then we have to assign here. We can be, but here we cannot use the statement that we used for the previous programs. That is storing in the accumulator. Okay. Directly use the for statement. For x equal to 0, x less than 8, x plus plus, x plus plus. For x is equal to 0, x less than 8, x plus plus. Then we are assigning P1.0 to D7, correct? We are assigning P1.0 to D7, ACC.7. ACC.7 is register A MSB, that is equal to P1B0. Register A MSB, that is equal to P1B0. Then after that, the bits have to be shifted, right? Therefore, ACC is equal to ACC greater than 1. Shift right by 1 bit. End the for loop first, then end the main program. Okay. Now, one more statement we can include here. Whatever value is there in accumulator, that we can see on the port. Some of port can be used either P0 or P1 or P2 or P3. So I will assign it to say P3 is equal to ACC accumulator. Okay. After all the bits, 8 bits are stored in the register A accumulator, then we can observe that data on port P3. Clear here? This is a program for moving the data 44H into the microcontroller through pin P1.0. And how we are moving the data? The LSB we are sending first. LSB we are sending first. Okay. Is this program clear here, students? This program is clear here. Any difficulty in this program? Shafia?
Understood, sir.
Understood? Okay. Let's move on to the next program. Take the program statement. Write a C program to bring in a byte of data serially, 1 bit at a time via P1.0. The MSB should come in first. Write a C program to bring in a byte of data serially, 1 bit at a time via P1.0. The MSB should come in first. Did you all note down?
Yes, sir.
Okay. Read the statement first. Before writing any program or any answer, read it first, understand, see what is given, what is being asked, right? Try to understand and then start writing the program or the answers. Write a C program to bring in a byte of data. We have to bring the data serially, 1 bit at a time through P1.0. Where we have to bring it? We have to bring it into the microcontroller, into the A register of the microcontroller. And how we have to bring it? The MSB should come in first. The most significant bit of the data that should come in first into the microcontroller, into the A register. Like that, we have to write a C program. Okay, it is clear that they have asked the C program, write a C program. Fine. Now let me explain the concept. This is just the opposite of the previous program. What do you think so? Yes or no? This is just the opposite of the previous program. In the previous program, they have asked to shift the LSB first. The LSB should come in first. Here they are asking to shift the MSB first. The MSB should come in first. Correct? So what all operations we performed for the previous program, we have to perform just the opposite operations, reverse operations for this program. Okay. The concept is like this. Here there is P1.0, right? Data of the P1.0, 8-bit data. Now here they are asking to send the MSB first. So this is the MSB. Again, we'll take the same data. It is 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0. Okay. This is the data. Now they are asking to bring this data which is in P1.0 in the port. Actually, P1.0 can store only 1 bit at a time. Okay. This is the data that is there, right? In the external devices, they want to communicate to the microcontroller. If they want to communicate to microcontroller, they are using the pin P1.0. Pin P1.0. Now they are asking to shift the MSB first. That means this is the MSB. This MSB will be stored in the position of LSB here, right? So first what we are doing, we are storing it here. Say 0 is stored. That is the MSB. Then after storing this MSB in the position of LSB of register A, what operation we have to perform to move the bits, to shift the bits? Whether we have to perform right shift or left shift? Whether we have to perform right shift or left shift?
Left shift.
Left shift, correct. Exactly, good. Here we have to perform the left shift. Okay. Left shift should be performed because these are the bits. This bit will come first. It will be stored here. Then shift it left. So this 0 will be shifted to next position. The next bit 1 will be stored. Right. So next time 1 will be stored here. In this position 1 will be stored. Okay. Then after 1 is stored, then the next bit, say this bit 0 will be stored. Next bit it is shifted. Okay. So we are shifting it. First 0, then 1, then this 0. So here 0 will come. 0 will come here in this position. Okay. So like this, all bits are shifted. Then this 0, whatever is there, that goes on shifting to the left, and finally it is available as the MSB. Finally, it is available as the MSB. At the end of all the 8 shifts, the data that is available in register A is 0, 1, 0, 0, then 0, 1, 0, 0. That is 44H. The same data what we wanted to send to register A of microcontroller, it is available after 8 shifts. After 8 shifts, the same data is retained in the register A of the microcontroller. This is the concept. Now, based on this logic, we have to write the C program. Let us write a C program. It is similar to the previous one, just slight changes here and there. Hash include hash include reg51.h, reg51.h, then define the variables that are used in the program. S bit, which are the variables we are using? One is P1.0, this P1.0 we are using, and register A LSB. Here we are using LSB. because we are shifting that MSB first to LSB of the A register. Okay, register A, that is P1 B0 is equal to P1.0. P1.0. Next, yes bit, register A, pin yes bit, register A, LSB, this is equal to which bit of A register? ACC 0.0. ACC 0.0, that is 0 bit of accumulator. ACC 0.0. Then write the main function, void main, then define, initialize unsigned character. Have they mentioned the data here? See here, they have not mentioned the data. Look at the program statement. C program to bring in a byte of data serially 1 bit at a time via P1.0. The MSB should come in first. There is no data which is mentioned, just it's a generalized program. Therefore, we need not write unsigned character shift byte is equal to 0x44. That statement need not be used. Okay, that instruction need not be used there. Just define the loop index unsigned character x, then write the for statement for x equal to 0, x less than 8, x plus plus, then next instruction what we have to use, we have to assign this MSB to LSB. We have to assign this MSB P1.0 to LSB of A register. That is, register A LSB is equal to P1 B0. Register A LSB is equal to P1 B0. Okay. Then register A LSB is equal to P1 B0. Then once we have done that, we have to shift the A register ACC left side, ACC less than 1, left shift by 1 bit. Then end the for statement, and then end the main program. Okay. Then as I told in the previous program, we can add one more statement here to see what is the output that we are getting in A register. You can check that. If you want, we can also store it in some of the ports. Say here I will use P2 port. P2 is equal to ACC. Fine. This is a program for moving the data into the microcontroller, for sending the data serially into the microcontroller via P1.0, and the MSB should be sent out first. The MSB should be sent out, or the MSB should be received in first into the microcontroller. Okay. Is this clear here, students? So you understood the difference between sending the data from the microcontroller out of the microcontroller, then receiving the data into the microcontroller. You understood the difference there, right? Accordingly, you have to study these programs. Okay. So one or two programs among these programs may be asked in examination. Okay. So make them perfect. Anything you want to ask here regarding these programs? Any doubts here? Any doubts in these programs? Was it understood? Logic is clear here? Bharti? Jyoti?
Yes, sir.
Understood the programs, today's program, Jyoti?
Yes, sir. Understood, sir.
Okay. Mantesh?
Sir.
Clear with all the three programs?
Yes, sir. Clear.
Okay. Nandish,
Yes, sir. Understood, sir.
any
Understood,
questions,
sir.
Nandish? Okay, right.
No, sir.
Okay, okay. Pooja, Pooja,
Yes, sir.
Pooja Patil.
Yes, sir. Understood.
Any
sir.
questions, Pooja? Okay, fine.
No, sir.
Okay, right. Shabaz,
Yes, sir. Understood,
Shab.
sir.
Any questions, Shabaz?
No, sir.
Okay. Shafia, Shafia.
Yes, sir. Understood, sir.
Okay. Any questions, Shafia?
No, sir.
Right. Srushti, Srushti.
Yes, sir. Understood, sir.
Any doubts here?
No, sir.
Okay. Abhishek, Abhishek, Palekar, Aishwarya.
Yes, sir.
Any doubts, Aishwarya? Anything not understood?
No, sir.
Any problem in understanding?
No, sir.
Okay, fine. Shodhan, Shodhan, Shodhan. Sridhar, Sridhar.
Yes, sir. Understood, sir.
Understood. Any questions, Sridhar?
No, sir.
Any doubts?
No, sir.
Okay, fine. So we'll wind up the today's session here. In the next class, I will be continuing with the next topics under module 3 that we'll take up in the next class. Okay. Thank you.